Okay, so now we will look at the implementation of the QADT as a double linked list. Okay, so the node class will have the three member variables, the data, the next node pointer, and the previous node pointer, and then the member functions to set and get the values. Now the Q class, which is the implementation of a double linked list, will have the head node and tail node. So that means you need to have the head pointer storing the address of the head node and the tail pointer storing the address of the tail node. So in the constructor, you will basically create the head node and store the address of the head node in the head pointer, and store the address of the tail node in the tail pointer, and set the next node pointer for the head node and tail node to null to indicate the queue is really empty. So this is how an empty queue will look like. The node next to the head node, the next node pointer for the head node is null, and the previous node pointer for the tail node is null. So you can have get functions to get the address of the head node and tail node. Using the get head pointer will return the head pointer, which stores the address of the head node, and get tail pointer will return the address of the tail node, which is stored in tail pointer. Now using the logic we just mentioned, we can check whether the queue is empty or not. So the head node's next node pointer is null. So get head pointer arrow get next node pointer will return the address of the node next to the head node. If it is null, then that means the queue is empty, so return true, otherwise return false. I can also check if the queue is empty by checking if the tail pointer is previous node pointer. So tail pointer arrow get previous node pointer, that means you're trying to get the address of the node previous to the tail node. If it is null, that also means the queue is empty. Okay. Alright, so now what we'll do is look at the enqueue operation. So similar to a stack, we'll have to deal with two scenarios. Is the queue empty before the enqueue or not? Okay, so let us look at the code and look at this example. So enqueue, you pass the data that you really want to enqueue. So new node pointer stores the address of the new node, and you set the data for the new node. Now remember, you're going to enqueue at the tail end of the queue. So there's no data node following this data node, and when you process the queue or the double linked list in the forward direction, starting from the head node, and the node next to the head node, as I said, is the node that is in the front of the queue. So as you traverse through the queue, the double linked list from the front to the end, after the last node, there should not be any node in the queue in the double linked list. So that's why the next node pointer for the tail node, not the tail node, the node that you're inserting at the tail end is going to be null. Okay. Now, so that's what I've shown here. So the next node pointer for the new node should be set to null in both the scenarios. Alright, now you try to get the address of that node previous to the tail node. So tail pointer arrow get previous node pointer. So they're trying to get the address of the node previous to tail node and store that in last node pointer. If last node pointer is null, so this is going to be similar to what we saw for a stack. If last node pointer is null, that means the queue is empty to begin with, because there's no tail node, there's no node previous to the tail node. So that means you have scenario like this. So then you can say head node's next node pointer is going to be the value of the new node pointer, and the tail node's previous node pointer is going to be the value of the new node pointer. And not only that, there's no node previous to this new node, because that's going to be the only node in the queue. So that can be also set to the. So the head node's next node pointer is new node pointer, and the new node's next previous node pointer is null. You come out of the else if block, you can say tail node's previous node pointer is equal to new node pointer. Now if last node pointer is not null, that means there's at least one node already in the queue. So try to do this now. So something like this. So last node really exists, so there's at least one node before the tail node. Alright, so now initially the last node's next node pointer is null because that's the last node in the queue. So now a new node is the last node of the queue, so we already set its next node pointer as null. So now we have to link it up with the rest of the double linked list. So the last node's next node pointer is going to be the new node pointer, storing address of the new node. So that is what this statement 4 is doing. Last node's next node pointer is new node pointer. And then new node's previous node pointer is last node pointer. So that's what this is doing. New node pointer, arrow set previous node pointer is last node pointer. And once you're done with that, you come out of the else block, and tail node's previous node pointer is this new node. So tail node pointer, arrow set previous node pointer can be now it's a new node pointer. Okay, so that's the enqueue, similar to the push operation when you implement it as a double linked list. So insertion is assumed to happen at the tail end of the queue. Now dequeue is done at the head end of the queue. So again we have to deal with scenario whether the queue is going to become empty after the dequeue or not. So let's look at the code for that. So we can get the first node pointer. So remember in the enqueue operation there's no looping. You have to just insert at the tail end of the queue, so this can be done in constant time. Similarly, the dequeue operation there's not going to be any looping, so it can be done in constant time. So try to get what is called the first node pointer, which is the first data node, which is the front end of the queue. So the data next to the head node. So head node next node pointer, head pointer arrow get next node pointer will get you the address of the front node, which is called the first node pointer. Then I use another pointer called next node pointer is null as initialized to null. Now pop data, which is the data you're really dequeuing from the queue, is initialized to some negative junk value. Now first node pointer is null, that means there's no real data node following the head node. That means the queue is empty. So you're trying to dequeue from an empty queue, so you should return that invalid value right away from this code. If first node pointer is not null, that means the queue is not empty. Then the next node pointer stores the address of the node next to the first node. And then what we can do is also get the data of the first node, because we're trying to isolate this first node. So before you isolate it, save its data in this temporary variable pop data. So first node pointer arrow get data stored as pop data. So now what you do is you check if this next node pointer is null or not. If it is null, that means after the first node is isolated, there's not going to be any other data node in the queue. The queue is going to become empty. So in that case, we have to just do something like this. The queue is going to become empty. How an empty queue looks like. Head node's next node pointer is null, and your tail node's previous node pointer is null. So that's what you have to do. Head node's next node pointer is null, tail node's previous node pointer is null. And then come out of the else block and return the pop data, which is the data of the first node that you isolated. Now, if the next node pointer is not null, that means there's going to be at least one data node after the dequeue. So the next node pointer stores the address of the node next to the first node. So you want to now isolate this node. So the head node's next node pointer can be set to the value of this next node pointer, so that it is pointing to the next node pointer, and the next node pointer's next node's previous node pointer can be set to null, because that way you have isolated the first node both in the forward as well as in the reverse direction. So when you set the head node's next node pointer as this next node pointer, you are cutting off this link. And when you set the next node's previous node pointer is null, that means you are cutting off this link to the first node. So the first node is kind of isolated over there, and that is logical deletion. So that's what we're doing here. Next node pointer's previous node pointer is null, and the head node's next node pointer is next node pointer. And then you come out of the if else block and return the pop data, which is the data of your first node. And the peek operation is similar to this. All you have to do is get the address of the node next to the head node, which is the first node pointer, and then check if first node pointer is null. If it is null, then return a junk value indicating that you're trying to read from an empty queue or peek from an empty queue. Now if first node pointer is not null, then let's return the data of that first node. Okay, so that we are done.